Find an approximation of the area between the curve y equals e to the x and the x-axis from x is 0 to x equals 2 using 20 centered rectangles. Given that the exact area is e squared minus 1 is approximately 6.389056099, and I think what that means is we're giving the exact value there to that number of decimal places. Find the approximate percentage error using these 20 rectangles. So if we think about e to the x, and we're going from 0 to 2, which obviously is an interval of width 2, using 20 rectangles. So 2 divided by 20 is 0.1. That is going to be the width of each rectangle. If we zoom in just on the first couple of these, so 0, and then the next one would start at 0.1 and go to 0.2. And the height of the first one, if it's a centered rectangle, would be taken at 0.05. And then the height of the next one is at 0.15, which means because the width's at 0.1, we're going up by 0.1. And the second rectangle would be here. And of course, the curve we're told is y equals e to the x. So if we're going to use a formula on the calculator, then it's probably going to be something like, at least something equivalent to 0.1 multiplied by e to the power of 0.05 plus y minus 1 times 0.1. That's going to give us the various heights. So when y is 1 for the first rectangle, we get just e to the 0.05, which is this height. And then when y is 2, then we'd get 0.05 plus 0.1, 0.15, giving us the height of this one, and then multiplied by the width. So something equivalent to that. You might not have come up with exactly that. Okay, so let's put that into the class pad and see what we get. So we're going to start off with 0.1, that's the widths, multiplied by the sum of the heights. So I'm going to use y as my running number. So y equals 1, this time up to 20 because we're doing 20 rectangles. Okay, and then that's going to be 0, oh, no it's not. It's going to be e to the power of, and then we're going to have 0.05 add y minus 1 times 0.1. And that ought to do it. So that gives me 6.386394768, giving the whole of the calculator display. Okay, so this was that value. And the exact value to this number of decimal places was this number just here. And in fact, we should be able to generate that on the calculator without a problem. We haven't taught you how to do this, so I'm going to do another one of these integrals. So, but you'll be coming to this, it's exactly what we're going to. So 0 to 2 of, and it would be e to the x dx, and there's that value. So if we want the percentage error, this one was the exact, so let's just put that in there. In fact, I missed, but let's sort that out. So I'm going to paste that. And then I want to see the difference with our approximation. So let's pop that one there. And then remember, it would be based on the true value. So you need to divide by the true value and then multiply by 100 to make it a percentage. And you can see that that is 0.042% difference. So it's pretty close with 20 rectangles.